Hi, my name is Ann Scanello, and I'm one of the tutors with the Seeds of Literacy program. Today I'm going to be teaching a lesson on algebra practice, and it's part 2 of a lesson that I've been teaching actually several versions over the last month. We're going to be talking about linear algebra. I'm going to be giving you some note pages, and this is information that will cover a significant portion of the questions on that GED. Okay, so on my previous videos, there's actually more than one. We've talked about the linear algebra vocabulary. So you could go back and watch some of those because I'm not going to review that today. And then I've also shown students the GED formula page because I think it's important that you're familiar with that before you go in to take the test. And that formula page actually looks something like this. This is not the whole formula page, but it's the algebra section of it. And so you could divide that into 2 sections. The top section is all linear algebra, and that's what we're going to be talking about today. And there are 3 formulas that they provide to you while you're taking the test. And honestly, y equals mx plus b, the slope-intercept form of the equation of a line, this would be the most important of those 3. And then, yeah, we're not going to go over that. The next thing I want to review that's also covered in my previous videos is understanding the parts of a linear equation. The linear equation, this is that equation that's on the formula page that I said this is the most important, the most helpful one. And it is y equals mx plus b. Well, you have to understand what that means in order to make sense of it and to use it when you're solving problems. So when you have an actual algebra equation in slope-intercept form, it won't look exactly like y equals mx plus b. You'll have the y and the equals and the x and the plus signs, but in the spot where we have the m and the spot where we have the b, numbers will be filled in. So when you actually see an equation in the slope-intercept form, it might look something like y equals 8x plus 5. Now also, x and y are typically the variables or the letters of the alphabet used when you're writing equations, but it's not always the letters that are used. Sometimes they will use different letters that help you to understand what's going on in the problem. For instance, if we're talking about total amount of time, they might use T. If we're talking about number of students, they might use N or S. The next thing, this was a set of notes, and I'd highly recommend that at this point you either get a piece of paper out to copy these notes, or I did have one student, when I had it all up on the screen, I paused and she was able to take a screenshot. But on the GED, they give you formula pages and they give you a handful of formulas. There is so much more that you have to memorize and understand walking in the door. And in 3 simple formula pages or 3 simple note pages, I cover almost all of that. So the first one is kind of understanding the y-intercept. So the y-intercept, if you're looking at a word problem, it's going to be the beginning amount or the starting point of the problem. For instance, if it's a problem about money, a lot of times you're starting off with no money and then, you're maybe making a purchase. Sometimes you're talking about draining a swimming pool, and if that pool has 10,000 gallons of water in it, your starting point is 10,000. And then they talk about how fast they drain the water out. So the y-intercept is going to be starting point or beginning amount. In a table, the y-intercept is going to be the value of y when x equals 0. So in my previous videos, we have lots of examples of word problems and tables where you can see when x equals 0, the value next to it is your y-intercept. Today, we'll also have examples of that, but this is the more advanced kind of basic mastery lesson. So the y-intercept, when you've got a graph, is going to be where the line crosses the y-axis. So on a coordinate grid or on a graph, we've got our y-axis that looks like this, and our x-axis that's horizontal looks like this. Wherever the line crosses that y-axis, that's going to be your y-intercept. And then in an equation, standard equation of a line or the slope-intercept form of a line is y equals mx plus b. This position where it says plus b, that's where you're going to look for your y-intercept. Okay, so at this point, these are the notes that you need on the y-intercept. You can go ahead and snap a screenshot, or if you have a phone, that you can take a picture of this screen, or if you could just jot it down real fast on notes that you're going to hang on to. Moving on. And then my next note page is calculating slope. Again, in a word problem, you'll recognize the slope because it's going to be the rate or the unit rate that they talk about. If we're purchasing items, let's say we're purchasing oranges and they're, $1.25 each. Well, the rate that you pay every time is $1.25. So for that problem, that would be our slope. Rate or unit rate, it's pretty much a synonym for the slope when we talk about linear relationships. In a table, and again, I'll show you an example of a table in just a minute, lots of examples on previous videos. In order to find the slope, you're going to take the change in the y values and divide that by the change in the x values. And then on the graph, remember we've got our coordinate grid with the x-axis and the y-axis. When the slope will be the rise over the run, and understanding what that means. The rise is how much, when we're reading a line from left to right, how much, when we're going from one point to the next point, how much do we need to rise, traveling along grid line, and how much do we need to run to get to our next point? We'll see some of that in a minute, lots of examples on previous videos. And finally, in an equation, that slope-intercept form of the equation of a line, y equals mx plus b, the slope is going to be whatever is in this m position. Whatever number is directly in front of the variable, adjacent to the variable. You'll also hear it called the coefficient of the variable. Just means whatever number is right there with x. Okay, again, this is a super important note page. Take a screenshot, use your phone to take a picture of it, or jot this down, because all of this is information you have to memorize before you walk in to take the GED or before you try to solve problems. So go ahead and jot it down. And there's one more page. I think I skipped it initially. We're going to go back and do that one. Understanding, oh, nope, that's not it. We'll get to it. We do have a third formula page, note page that I want you to write down, but we'll get to it in a minute. Okay, we're going to go ahead and start the basic mastery skills. So we're going to skip over all the practice we've been doing in the last several weeks. And so this is a typical problem. This is an example of a graph, and you might be asked to find the slope, the y-intercept, and then also write the equation of this line. Okay. We've talked a lot about this, lots of videos on this from lots of different teachers. But in order to find the slope, we need to look at that note page that we just took. So, oh, whoops, that's not going to work. Hold on. Okay, so the note page looks like this. So our problem was a graph. And so we need to look at rise over run. So this is going to be an example of how to use the rise over the run. Okay, so in order to find the slope, rise over run, we need to identify 2 points on this graph. And they need to be specific points because they need to travel through grid lines. So when I say grid lines, you can see the y-axis is a dark black grid line. The x-axis is a dark black grid line. But we also have these gray ones. And so we need points, if I put my pointer on, we need points not like this one that I have my pointer on right now, because while it travels through one of my gray grid lines, it does not travel through 2 of them. We need points like these 2, where it travels through 2 gray grid lines. We know the exact location of those points. So I found that I've highlighted 2 of those points. Now, when we're reading a graph, it's just like when we're reading a word or a sentence, we always go from left to right. So I start at the point on the left, and I have to rise, which obviously we're not rising or going up to get to my second point. We're falling. What that tells you is, oh, wait, this is going to be a negative slope. Okay, we're sloping down, going left to right. So, but we call it rise. It's a negative rise means you're going down. So I need to count, going along grid lines, traveling from this point to this point, how much do I have to rise? That'll be -1, -2, -3, -4, -5, -6, -7, -8. -9 is my rise. Now I'm right here. I need to travel along the grid line, and I need to run. That means I'm going along the x-axis, or I'm horizontal to the x-axis. So I'm right here, and I'm running 1, 2, 3 spaces. So in order to find my slope, it's going to be my rise was -9. I actually went down 9 spaces. And then my run, I ran over 3 spaces. Now we have to simplify that. That is a fraction. It's an improper fraction. And so we want to simplify that something more normal looking, like -3 divided by +3 is a -3. Okay, so now my y-intercept, and I would love to take you to that y-intercept note page, but I'm not going to do that because it's going to mess up all of my locations. But hopefully you took down the notes. When you find the y-intercept on a graph, find the line wherever it crosses the y-axis, like this is the y-axis, that number is the y-intercept. So in this case, the y-intercept is the number 6. Simple enough. Y-intercept is the number 6. Now we need to write the equation. And remember, standard equation of a line or slope-intercept form of the line is y equals mx plus b. So we know it's going to start y equals, instead of m, we're going to fill in the slope, which is -3. And then we're going to put down our x, and then we're going to say plus, and instead of b, we're going to put down the 6, because that is our y-intercept. And our equation will look like y equals -3x plus 6. This was a relatively simple problem to solve. This is typical for what you might be seeing on the GED. If you have those 2 note pages memorized, life will be much easier. There was my slope. So there was my Y-intercept page. Here is that other note page, and I am going to pause so you can take a picture of this or jot this down. When you have an equation in the slope-intercept form, y equals mx plus b, y is always going to be your dependent variable. It's the total of what you're solving for. Total amount of money, total amount of time, total temperature, something. The m is going to be called the slope. You're also going to hear a synonym, unit rate. It's also the m. Whatever the unit rate is in the problem, it goes in this position. Constant of proportionality. I was looking at a lot of GED practice tests, and I was really surprised that one of them actually was referring to finding the constant of proportionality. First of all, if you have a linear relationship, that just means that if you put it on a graph, it's going to graph out to be a straight line. Anything that graphs out to be a straight line is going to be proportional. So the constant of proportionality is just the same thing as the unit rate or the slope. It's another term to use, and they're kind of testing to see if you understand that that constant of proportionality is the same thing as the slope or the rate. Another term that you might hear is coefficient of x. I've already touched on this a little bit. Anytime you hear someone say coefficient of x, all that means is what number is right in front of x, or if it's the coefficient of the variable. It just means they're talking about the number that comes right before the variable. And then we have plus b. We've already said this position in the equation is the y-intercept. If you're talking about a word problem, it's the beginning amount, and it's also the value of y when x equals 0. Okay, so now have we done this one? Okay, going for our second practice problem. Okay. Another problem, very similar to what we just did. Okay, so now we need to find the slope of this line. So again, in order to find the slope, when they've given us a graph, we have to identify 2 points that we know the exact values of. And we know the exact values when the point, get my pointer back on, when the point is not crossing one gray grid line, but then in the middle of a space, it's where the line crosses 2 grid lines. So let's see here. We've got, there's an example of a point where the line crosses 2 gray grid lines. There's another one, and another one, and another one. I'm not sure if I marked another one or not. You might, in the graph, have any number of points that you have the exact value of. You can pick any 2. It doesn't have to be the farthest apart or the closest together. You pick any 2. I'm going to pick this one right here, and I'm going to travel from left to right, because when we read a graph, we're always traveling from left to right. So I'm at this point, and my slope formula was rise over run. I'm at this point, and I need to rise traveling on grid lines. I'm going 1, 2, 3. Now I need to travel over to get to my second point, and I only travel 1 space. So that means that my slope is, my slope is 3. It's 3 over 1, which is the same thing as writing 3. Okay, so my y-intercept, again, the y-intercept, we just look at the line and we say, where does it cross the y-axis? So even though I can't hear you, Go ahead and tell me, what's the y-intercept for this problem? And it would be 6. So we know that the slope-intercept form of the equation is y equals mx plus b. So tell me, what would the equation for this relationship be? Did you say y equals 3x plus 6? The slope goes in the m position right in front of the variable, and the y-intercept is that number added on. There's my slope note, my y-intercept note. There's the notes on the slope-intercept form. Okay, now here is another basic mastery problem, but we're starting with a table this time, and this is a little trickier problem. So if you remember, I can make this work, when we're trying to find the slope using a table, the notes told us we're going to find the change in y, and we're going to divide that by the change in x. That's not it. Okay, so we were on the table. Okay, so we need to find the change in y, and we're going to divide it by the change in x. So let me show you what that means. The change in y is, we look down at our values of y, and we say, how much does it change from the first value to the next value? Going from -10 to -7, it goes up by 3. Let's test it through the whole table. -7 to -4, how did it change? It went up by 3. -4 to -1 went up by 3. -1 to +2 went up by 3. Sometimes it may be easier to look at the positive section of the table to tell that 2 to 5, oh yeah, it is. It's going up by 3 every time. So our change in y is going to be a +3. So how is our x changing? -6 to -4, it goes up 2. Goes up 2 from -4 to -2, -2 to 0, also goes up 2. Easier to see when we're positive. 0 to 2 goes up 2, 2 to 4 goes up 2. So our slope was +3 over +2. Now that's an improper fraction, but when we're writing equations and we're working in algebra, I actually prefer to leave my answers in improper fractions. So that's fine, leave it just the way it looks. Okay, now our y-intercept. We said that in order to find the y-intercept on a table, we need to find the value of y when x equals 0. So we need to go back to our table and look for the spot where x is 0 and look right next to it and say, what is the y value? Try this. And now we're going to have to do this. Okay, we find our x value is 0. The y value when x is 0 is -1. So our y-intercept then is -1. Now we have to write our equation. Remember, standard equation of a line, y equals mx plus b. Mx is our slope. Just going to put in 3/2. Our y-intercept is -1. So our equation is going to look like this. Y equals 3/2 x minus 1. Now I'll get some students to say, what do you mean -1? I thought we added on the y-intercept. Yeah, we do. And a lot of students will write y equals 3/2 x plus a and -1. And that's fine, because plus and -1 is the exact same thing as -1. You'll find, though, that more mathematicians will write, instead of saying plus a negative number, they will just write that as subtraction. Note pages. Okay, here's another table. This is a really tricky problem. But the slope, let me see, we said when we had a table to find the slope, we're going to find the change in y and divide that by the change in x. So our y values are right down here. So from 4.5 to 4.0, what's our y doing? It's going down by 0.5. So that would be like a -0.5. Okay? And we could just test it to make sure that it's a linear relationship, that it is doing that constantly throughout. 4 to 3.5, yep, we subtracted another 0.5, subtracted another 0.5, subtracted another 0.5, subtracted another 0.5. Okay. Our x values in this table do what x values do in a lot of tables. They go up by 1 every time. So our slope is going to be the change in y. That was a -0.5 or -0.5 over our change in x, which is 1. So our slope is going to look like this. Mathematicians don't write it like that. Any number over 1 is just itself, so you're going to see it written as a -0.5. Y-intercept is very tricky on this table, and we did a lot of practice problems like this on my previous videos. The problem is, in order to find the Y-intercept, we need to find where x equals 0. On this table, they didn't tell us where x equals 0. It's our job to figure that out. So that's okay, we can do that. We found the pattern. We know that if x was 0 right here, that our number here, we would be able to say this number minus 0.5 is 4.5. Minus 0.5 is 4. Minus 0.5 is 3.5. So this number, the y coordinate when the x equals 0, is going to be 0.5 larger than 4.5. It's going to be 5. Most students understand that once they've seen it, but it can be tricky when you first start working these problems. Good to practice. Okay, now our equation's easier. Y equals mx plus b. So y equals negative 0.5x plus 5. Note page, note page, note page. Okay, this is the equation, and this should be relatively simple. So they told us the equation this time, y equals 2.5x plus 5. And it's our job to tell the slope. Where do we look in an equation to find the slope? We look at the number right in front of x. What number goes with x or goes right in front of it? And that is 2.5. The y-intercept, how do we find that? That's that number that's just added on, that doesn't have a variable with it. That's 5. Our equation, again, y equals 2.5x plus 5. Note page, note page, note page. Here we go. We have another equation. This is a little trickier. It's not too tough if you've practiced it, but if this is a problem of this type that you've seen, it might be a little trickier. We need to come up with the slope. And we know the slope intercept form of the equation is y equals mx plus b. We know to find the slope, we need to look at that number that's directly in front of the variable x. So what is that number? That number is -3. The slope, even though the slope intercept form is stated y equals mx plus b, the slope, or the term that has the slope in it, doesn't always have to come first. The commutative property says when we're adding two terms together, it doesn't matter. Like if we say 2 plus 3 equals 5 or 3 plus 2 equals 5, we can move those add-ins, we can flip-flop them, and we're going to get the same answer. So that's all they've done in this equation. It is still a linear equation. They just flip-flopped our add-ins. And so we found our variable x, and we said, what number is right in front of it? What is the coefficient? A lot of students would say 3, but remember, minus 3 is the same thing as plus a negative 3. We need to think of all linear equations as addition. So we're responsible for understanding that minus sign goes with the 3. So the slope was negative 3. Definitely a trickier problem. Now the y-intercept, let me see. So the y-intercept is the number that's added on. Well, technically we don't even see an addition sign in this problem, but can you tell me what the y-intercept would be? Hoping you said 20, because it is. This could have been written y equals negative 3x plus 20. Had they written it that way, I think everyone would have gotten the answer correct. Note page, note page, note page. Oh, this is more practice from the packet. I got some of the algebra packets from the SEED program. And so this is just a few examples of the types of problems that you'll be practicing in their packet. So the first one, we have to take this equation, y equals 3x minus 4, and we have to graph it. And they've given us our little grid here. We need to graph it. And so we say to ourselves, I say to myself, what is the easiest point? They've given me an equation. What is the easiest point for me to find on my graph? And I always think that that's going to be the y-intercept. So from the equation y equals 3x minus 4, what is the y-intercept? Can you tell me? Hoping that you said negative 4, because it was minus 4. Remember, you can think of that as like plus a negative 4. That means that the first point that we know is going to be on our line is going to be the y-axis, negative 4. Okay, so now from here we need to find a second point. And they've given us the equation. And from the equation, we know that the slope is what? 3. The slope is 3. We also remember that the slope is rise over run. So now I know if I can state my slope of 3 in fraction form, my job's going to be easier. So how do I state 3 in fraction form? 3 in fraction form is 3 over 1. So my rise is going to be 3. So here I am. I'm starting at my first point, which is my y-intercept. And I know to find my second point, I need to rise 3. 1, 2, 3. And my run was 1 because I wrote 3 in fraction form, so it's like 3 over 1. So now I need to run 1. I'm going to go 1 to the right. And that is my second point. If I wanted to continue plotting points on this graph, I could do that. I could keep saying, rise 3, 1, 2, 3, run 1. Oh, look, there's a point. 1, 2, 3, run 1. Oh, look, there's a point. But honestly, I could have drawn my line after I found my first 2 points. You only really have to have 2 points to draw a straight line. I'm just the kind of person, I like to continue to make sure that I don't have any miscounts or I haven't made a mistake somewhere. Another type of problem that they're going to have you practicing in the algebra packet looks something like this. And there's a lot going on here. Now, I'm going to say there are several ways to solve the same type of problem. And so the packet is kind of driving you to solve it one way. I personally feel like there might be simpler ways to solve it. So we're going to go over a couple of those ways. Okay, X-Intercept. We haven't talked about X-Intercept at all. I'll talk about it briefly in just a minute. Y-Intercept. We know a lot about Y-Intercept. And let me see, our equation here is y equals 3/4 x minus 1. Okay, from the equation, can you tell me what the Y-intercept is going to be? Hoping you said, oh, sorry, we're graphing over here. Okay, hoping you said -1, and you can see that we've marked -1 on the graph. So x is 0, and the Y-intercept, it crosses at -1. Oh, so then our slope, what's our slope going to be? Our slope is going to be 3/4. Well, that was convenient. They already stated our slope for us in fraction form. That actually helps us. So in order to graph our line, we're going to rise 3 and run 4, because slope is simply the rise over the run. Okay, so I'm going to rise 3, 1, 2, 3, run 4. 1, 2, 3, 4. Oh, look, there's our second point. Rise 3, 1, 2, 3, run 4. 1, 2, 3, 4. Oh, ran off the graph. We could have done that backwards and come up with more points there. But we have our 2 points, and I think we now can draw our line. So didn't even use their table of values. Just from the equation, we were able to graph the line. But let's go ahead and talk about the table of values and filling in the X-intercept, the Y-intercept, and the slope here at the bottom. So I'm thinking I filled in, there we go. Our Y-intercept was -1, and our slope was 3/4. We've practiced that a lot. Fairly simple skill that they love to test on tests like the GED. Okay, so now I'm going to need the X-intercept. The Y-intercept means where does it cross the Y-axis. The X-intercept just means where does it cross the X-axis. This is a strange problem. It's a pretty high-level problem for the place they had it in this packet, I thought. The X-intercept does not go through a spot where 2 grid lines cross. So looking at the graph, I know it's somewhere between 1 and 2 on the x-axis. It appears that it's closer to 1 than it is to 2, maybe 1.2, 1.3, 1.4, something like that. But it's going to be tough to estimate it just by looking at the graph. So they gave us a table of values to fill in. Let's go ahead and try doing that. So the table of values, they've given us x values, and they want us to substitute these x values into this equation. So instead of having 3/4 x, or 3/4 multiplied by x, we're going to multiply 3/4 times by 0, putting the 0 in the spot where x is. So that's going to be 0 minus 1. So our y value would be -1. Now we're going to substitute a 2 in this. So 3/4 multiplied by 2. So we're going to multiply straight across. So 3 times 2 is 6. 4 times 1 is 4. 6/4. And then we can simplify that, dividing top and the bottom both by 2. And that's going to be, did I mess up? I think I messed up. Okay, 6/4. That is the incorrect answer. That is, we've gone astray on this problem. Okay. We're going to substitute a 4 in here for our x value. And if we say 3/4 times by 4, it's like 3/4 times by 4 over 1. Let me draw this out for you. It's going to be 3/4 times by 4 over 1. And I'm not sure. There we go. Hopefully you can see that. I'm not able to see what you guys are looking at. So now we have to do 3/4. The 4s are going to cancel out. I'm left with 3 minus 1, and it's going to equal. It's going to equal 2. Okay, and I just realized my mistake before. I was like, I confused myself. Easy to do. Okay, I was substituting the 2 in for the value of x. And so that would be 3/4. I'm going to substitute 2, but I have to multiply them, so I like 2 to be in fraction form. And now I'm going to minus 1. That's what I was forgetting to do, was subtracting the 1. Okay, so I'm going to simplify here. Divide by 2, so that'll be 1. That'll be 2. So it will be 3 halves minus 1. That's where I messed up. 3 halves minus 1 is going to be 1/2. Okay. So now, this is why I thought this was a really advanced problem for where we were in this packet, because we've done all the work they've asked us to do, and we still don't have our X-intercept. We still don't have the value of X when Y equals 0. We can get it, but we're going to use the symbolic method. And I've also done videos on that. A lot of the other tutors have done so as well. I'm just going to show you quickly what that would look like, and you can go back and you can practice that. So we need our Y value to be 0. So our Y value is 0 equals 3/4 X minus 1. And now we need to solve for whatever X is, because that's going to be where our line crosses the X-axis. Add 1 to both sides. That's going to cancel. So 1 equals 3/4 X. So now I need to divide both sides by 3/4. I'm going to say divided by 3/4. Divided by 3/4. Okay? And 1 divided by 3/4 is the same thing as 1 times by 4/3. It's going to leave us with X. So X equals 4/3, which is the same thing as 1 and 1/3. That, like I said, that's the symbolic method. That's another whole lesson. But that's what it would take to get to the X-intercept. I will say, when dealing in linear algebra, it is rare that I have seen standardized tests or textbooks ask questions about the X-intercept. That was unusual. I thought that they put it in this packet. Okay, and I think we've got one more problem. This one is similar. Our equation was Y equals X plus 2. We have to fill in a table of values, but this time they're letting us pick our X values. And this is really pretty common. That's why I wanted to show this example. They want us to graph the equation again. And again, they want to know the X-intercept, the Y-intercept, and the slope. Okay, so I'm not sure what I decided to start with here. There we go. Y-intercept is 2 because it's the number that's added on. The slope, what's the slope of this one? when I did practice problems in my earlier videos, we did several of these, but what is the slope here? Because it's supposed to be the number in front of x, and there's not a number in front of x. So what number does our brain, or what number do we understand is in front of x or multiplied by x? That would be 1. Our slope is 1. Okay, so now I think I went ahead and filled in the table of values. I did. Whenever they let me choose my x values, I can choose any numbers that I want. But I'm a keep it simple kind of person, so I choose numbers that will be easy for me to work with, that hopefully will be 1 digit apart, because that'll make them easy to graph. So I almost always choose 0, 1, 2. I've seen some people choose negative numbers because it shows them a part of the line in the negative portion and in the positive portion. I don't do that because I find that students have more trouble working with negative numbers, so I just keep it positive. Okay, so now I substitute 0 in where it says x. So it's like y equals 0 plus 2. So y must be 2. Now I'm going to substitute 1 in. So where it says x up here, I'm going to substitute 1. So y equals 1 plus 2. Y must be 3. Substitute 2 in for x. Y equals 2 plus 2. Y must be 4. Okay. So now I could fill out my graph the same way I did on the last problem. I could say my y-intercept is positive 2. My slope is 1. I'm going to turn that into fraction form. So it would be 1 over 1. So I'm going to rise 1, run 1, rise 1, run 1. I could do that. Or I could plot these points. I have 3 points that I just came up with. So let's see here. I plotted the point 0, 2. I plotted the point 1, 3. I plotted the point 2, 4. I could continue plotting points. My slope is 1. So I'm going to rise 1, run 1, rise 1, run 1. But I don't have to do that. There's my line. Okay. Now, this time, my x-intercept is a little easier to see from my graph. It's going to be a negative 2. This was more the type of problem I expected to see on this packet, where you had a relatively simple way to find the x-intercept. And I think this is the final problem. Okay. Again, we're graphing. Here's our equation. We're going to graph straight from the equation. What's our y-intercept? 6. Put my y-intercept up there. So where x equals 0, crosses the y-axis at the number 6. What's my slope? Don't forget the minus sign stays with that 3. So it's going to be a negative 3. Negative 3 in fraction form would be like negative 3 over 1. So negative 3 is going to be the same thing as negative 3 over 1. I write it in fraction form because now I know I'm going to have to rise negative 3. So I'm not actually rising. I'm going down. And I'm running 1. So let's do that. Okay, so I'm rising negative 3, going down. 1, 2, 3, running 1. Rising 3. 1, 2, 3. I'm rising negative 3, sorry. Running 1. Right there. I can continue doing that, marking points. I don't really need to. 2 points gave me enough for a line. There is my line. In the packet, I think they were kind of steering students towards creating your own table of x values. Easy to do. You could have figured out x is 0, x is 1, x is 2. You could have said if x was 0, so that'd be 6 minus 0, y would be 6. If x was 1, 3 times 1 is 1, that would have been 3, 6 minus 3. So it would have been 1, 3 would have been our point. If x was 2, 3 times 2 is 6, it would have been like 6 minus 6 is 0. Would have found that point. And think that's it. Nice job. Okay, I covered a lot. I'm sorry I'm using a presentation from before. I was wanting to be able to go back and forth the earlier parts of the lesson. Made it a little challenging to carry it off, but I hope you didn't mind too much. Anyway, have a great week, and hopefully we'll be back in the classroom soon. See you later.